What we are going to look at is how to explore univariate data. And you can see here the 4 steps necessary to explore univariate data. So before we go too much further, let's first talk about what univariate data is. Univariate, right there, means one variable. And I'll erase this to make it look a little bit better there. So univariate data. So right now we're going to talk about data of one variable. Okay. The first thing we're going to do is to graph the data. We should be able to do this after chapter 1. The second thing we need to do is look at our SOCs. So SOCs is an acronym. It stands for shape, outlier, center, and spread. So SOCs is shape, our outlier, our center, and our spread. And we need to discuss all 4 of these things when we discuss our data. Shape, outlier, center, and spread. And the acronym we use will be SOCs. Kind of like the ones you put on your feet, but without a K. Step 3 is to calculate the numerical summary. That means to find the mean or median or whatever else we're trying to do. We'll discuss a little bit more coming up. And the last step is to see if the data can be described by a curve or a mathematical model. So write that down for right now, and we'll come back and discuss what some of this actually means. So before we go too much further, I want to bring up a couple things. The mean we're going to call mu, and the standard deviation we're going to call sigma. This mean here is mu, like what your cat says. And this is sigma, and this is a lowercase sigma. And just so you know, this is mean and standard deviation of the population. And we'll discuss more later on in this course and as we go on about how to know by looking at the symbols and the abbreviations if our data is referring to a population or a sample. And just a quick reminder, population is everybody in the group that we're looking at. So it could be all cars, for example, all cats, everybody in 10th grade at Palmdale High School. All of those could be populations. Okay. So let's go on and talk a little bit more about some things. And there's some things that we need to understand. The first thing is that probability is area under a curve. That's all it is. So for those of you who had calculus, this should look very familiar. Now, even if you didn't have calculus, that's fine, but those of you who've taken calculus should be very comfortable with area under a curve. And that's what probability is. So let's talk about a density curve. And a density curve has to have 2 separate properties. One of these properties is that the total area under the curve is 1, because total population can never be more than 1. Or I'm sorry, the population event can, or the probability event could always occur is 1 or less. So the total probability something could occur is 1. And it's always positive. We cannot have any negative probability. I don't even know what that means. So it says here that a density curve is a mathematical model of the data. And it's just that. It's a model. It's nothing that's perfect. It's a model. It's something that attempts, and attempts to is a key word. So a mathematical model attempts to make a fit for the data. And I say it attempts to do so because we're not always successful. So that's what a mathematical model is, or a density curve rather. A density curve is a mathematical model, and its job is to attempt to make a fit for the data. We'll learn more about this coming up, but we need to know these two things about a density curve. Total area is 1, because if we add up probability, probability always and it's always positive. Now let's talk a little bit about SOCs. I told you there's a couple different parts to SOCs, and the first S is shapes. And here are 3 different types of shapes. The first is symmetric, the second is skewed, and the last is uniform. And there are some other shapes as well, but these are the 3 that we're going to discuss coming up. So let's look at a model here. Or I'm sorry, let's look at a graph of some data. Let's figure out what shape this is. So as we're looking at this, we try to determine what the shape is. So I'm going to draw a little curve to this data. And the data looks something like this, where it has a long tail over on this side. This is skewed left. Why? The tail is left. And this is the tail here. The tail is a longer part, just like on your dog, unless your dog doesn't have a tail. But like on most dogs, the tail is longer than the head, and we're skewed in the direction of the tail. So this data here is skewed left. You can see this curve has already been fitted with some type of dotted curve. You can also see there's a tail on the right this time. This is a tail here. So this one is skewed right. Let me fix my W a little bit here. Skewed right. And again, it's skewed to the right because skewedness is always measured in the direction of the tail. This is a uniform distribution. It's uniform because all the bars here are just about the same height. Statistics, unlike some other types of math, understands that data in the real world is not perfect, and as long as it's pretty close, and we can justify it with some word like approximately or about, we can call it a uniform distribution. So I'd say this is approximately uniform or about uniform. But this is uniform because all of the bars or all of the data categories are all the same height. And this last distribution that we're going to look at for right now here is symmetric. And you'll remember symmetric means we can cut it in half if about the same on each side. So if we cut it in half down the middle here, we've got about the same on each side. So we will call this approximately symmetric. You can also call this mound shaped because this looks like a big mound. Okay, so that's my shapes. The next thing I want to look at are my outliers. So let's take a look at outliers real briefly. Here are my outliers. And here are the definitions of outliers. Outliers are either more than 2 standard deviations. So we have the center, which is our mean, which is our mu, plus or minus 2 standard deviations, or Q1 minus 1.5 IQR, Q3 plus 1.5 IQR. That's our shape and our outliers. And here's our center. Centers will measure either with mean or with median. Now you'll notice on this last slide that I put mean and standard deviation together, and I put median and IQR together. Let's go back to center. Sorry about that. And there's a reason for that. The reason is that mean and standard deviation go together, and median and IQR go together. Just to let you also know, there is no standard abbreviation for median. I'll oftentimes use M, or I'll use an M with bars under it. And the bars just help me denote that for M from a M versus a median. So we have our shape, our outliers, our center. The next thing we need to know is spread. And there's three different types of spread: standard deviation, IQR, and then range. And range is your maximum, that's your biggest one, minus your minimum, and that's your smallest one. And that is the basics of it. I'm going to cover one more thing real quickly. Actually, I won't. I'll just go ahead and close with that. And then here's a little reminder. Skewedness and the mean and the median. The mean is pulled by the tail in the direction of the tail. The mean and median are the same for a symmetric curve.